So this is where we left off yesterday, verifying that these two functions are inverses. Now, to show that two functions are inverses, or to see if they are inverses, one thing has to hold true, that f of g of x is equal to g of f of x, and both of these have to equal x. So if f of g of x is the same as g of f of x, and they're both x, then the two functions are indeed inverses. If one of them is not equal to x, then they're not inverses. So the first one of these that we can look at is f of g of x. And when we look at f of g of x, the first thing we're going to do is plug x into g of x. And when we plug x into g of x, well, we're just replacing x with x, which more or less just gives us x plus 1 over 3. We just get the function back. Doesn't really change anything. You're good. Any questions on this so far? Now for f of x plus 1 over 3, every place where there's an x in f of x, we're going to replace it with x plus 1 over 3. So what we get is 3 times the quantity, because we're replacing x, which is x plus 1 over 3 minus 1. Now at this point here, we do need to simplify, so the 3 and 3 here cancel out. X plus 1 minus 1, which is x. So we're able to show that f of g of x does equal x. Now we just need to show that g of f of x, the other composite function, also equals x. Now just like the last one, this time we're going to plug x into f of x, which is just going to give us 3x minus 1. And similar to the last one, every place that there's an x in g of x, we're going to replace it with 3x minus 1. So we have 3x minus 1 plus 1 all over 3. So we could say 3x minus 1 plus 1. We can drop the parentheses. But the negative 1 plus 1 is 0, just leaving us with 3x divided by 3, which is x. So we are able to show that f of g of x is the same as g of f of x, and both of them are x. So these two functions here are indeed inverses. And we actually kind of knew that from the beginning, because the instructions told us to verify, show that they are. But that's it. Any questions on this here? We're going to look at another one of these here. We want to verify that these two functions are indeed inverses. So the first thing we can do is look at f of g of x. And our first step in doing this is plugging x into g of x, which is really just going to be x minus 4 over 2. And now we plug x minus 4 over 2 into every x in f of x, which gives us 2. Our x is now x minus 4 over 2. And we have plus 4. At this part here, the 2 and 2 would cancel, telling us that x minus 4 plus 4 equals x. Now that we've shown that equals x, we can look at g of f of x. Now we're going to plug x and f of x, or really just replace f of x with its expression. So we have g of 2x plus 4. Now we replace where x appears in g of x. We're going to replace it with 2x plus 4. So we have 2x plus 4 minus 4 all over 2. Well, the numerator after we drop the parentheses is 2x plus 4 minus 4, which just tells us that it's 2x over 2, which simplifies to x. So we're able to show that these two are indeed inverses, because f of g of x is equal to g of f of x, which are both equal to x. Now, even if they were the same thing, they both have to equal x. If they both give us something other than x, they are not inverses. Questions on any of this here? We good with this here? The last two that we're looking at, these are a little different because these we want to determine whether the functions are inverses or not. Now, for the first one's not too bad, because we can do the same thing, f of g of x. Well, g of x in this case is x minus 5. So now we're taking f of x minus 5, so we're replacing every x in f of x with x minus 5, telling us that we have x minus 5 plus 5. Which is the same as saying x minus 5 plus 5, which is just x. So that is looking good. We still just need to make sure that g of f of x doesn't give us something different. And at this point, we're going to replace f of x with its function, x plus 5. And just like the last one, this time we're going to plug x plus 5 into every x in g of x, giving us x plus 5 minus 5, which ends up giving us x. So these are inverses. Is f of g of x is equal to g of f of x, which is equal to x. Questions on any of this here? Last one we're going to look at. So the first thing we can do with this here, determine if they're inverses, is just look at f of g of x. Now we could do g of f of x first. It really doesn't matter which. We just need to pick one of them. And the first thing we can do is plug x into g of x. And if we do that, we just end up with the cubed root up to x. And if we plug the cubed root of 2x in for every x in f of x, we get 8 times the cubed root of 2x cubed. Give you all a second to write. Now at this point here, we know that the cubed root and the third power will cancel, giving us 8 times 2x. When 8 times 2x is equal to 16x. So is that what we wanted it to be equal to? So are these going to be inverses? No. At this point, we can just say not inverses. Because if one of them doesn't equal x, it doesn't matter what the other one equals, because both of them have to equal x. Now, I'm going to go on and do the other one. You don't have to put it down if you don't want to. G of f of x, if we did this the other way, we would plug in our 8x cubed. Then we would plug this into g of x, giving us the cubed root of 2 times 8x cubed. Now we can multiply these together, giving us 16x cubed. And if we do take the cubed root of it, we get 2x cubed root of 2. Well, these are not obviously not the same, and they're both definitely not equal to x, so they are not inverses. Any questions over anything we've done so far? That's it.